Productions. Well, welcome. Welcome to this presentation. We have now James, let me see, Jameson Watts. I needed some cue there. Jameson Watts from Willamette University. You are right. You are managing or coordinating the data science program. Is that right?
Yeah, I have a fairly kind of academic sounding title. So I'm chair and director of the computing and data science programs at Willamette University. So what that means is that I oversee both our undergraduate programs in computer science and data science and our graduate programs in data science. And then coming up, we have a new program in computer science at the graduate level that will be coming online in fall 24.
Oh, perfect. Yeah, we, before starting this recording, we were talking about how technology keeps evolving and always creating opportunities and challenges in general, right? But let's start from the beginning. I have a few questions for you, and just considering that this conversation is going to be watched by like people who have no idea about what data science is. They might not have idea what data is, even what data analysis is. So can you share a little bit what's the difference between data science and doing just data analysis, working with Excel, for instance? What is data science?
Working with Excel and doing data analysis, kind of more traditional analytics work, it's kind of a gateway into data science. There's actually no bright line distinction between the two in my view. When you talk to professionals in the field, when they use the term data science, they're often referring to a very specific portion of the analysis process. And that portion is the modeling process. So running the machine learning algorithms or the linear modeling algorithms to design, to derive some insights from data that go a bit beyond, summary statistics and data visualization and those sorts of things. However, in my view, data science is really a catch-all term that covers everything from data quality, governance, ethics, privacy, all the way through the data architecture and then the statistical modeling as well.
Yeah, there's when we go to community events, and that's also, I'm coming from an academic background as well. It's really hard sometimes to translate these technical terms into more like easy to digest, explaining what machine learning is. It can be challenging, right?
It can, although, most folks are a little scared by the idea of machine learning, but when you actually get into the nitty-gritty and start diving into the details, it's not all that complicated. You've got a computer program and it's just trying to figure out how to navigate its way through a bunch of data to find patterns. And we have a whole bunch of different computer programs that do that kind of thing. Anything from a simple linear regression model, which you may have done in high school, all the way up to something as complex as a deep learning convolutional neural network, right? Which is kind of the state-of-the-art type of thing that you might use in computer vision, or some of the kind of emerging machine learning topics. But all of these things and everything in between, decision trees, random forests, logistic models, these are all just different computer programs that are trying to find patterns in data.
Yeah, I think that's the key word. Identify patterns. And you know, I have an 8-year-old and we play with that. So how we can, where is the pattern here? Where is the pattern there? And that's actually a fun thing to do. You know, for somebody who wants to start in this world, what would you recommend that person to do? Like, you know, just regular, uh, somebody from high school, let's put it like that. Somebody from high school wants to start a career in data science. So what would you recommend?
So I have a bit of a kind of tongue-in-cheek definition of a data scientist, and that is a mediocre programmer paired with a mediocre statistician. But the overlap is incredibly valuable, right? If you know just enough programming, you know, to be dangerous, and you know just enough statistics where you can kind of understand what's going on under the hood in some of these models, there's a huge amount of value at the intersection of those two skills. And so when you think about trying to get started in, you know, kind of data science as a profession, you have to think on two fronts. On the one hand, you need to develop a few skills in programming. And on the other hand, you need to develop a few skills in statistics. And when I talk to high school students, which I do on occasion, I give them the same answer. If you're talking to a professional or someone who's a bit older, often I ask them what their background is. And if their background is more on the computer science programming side of things, you know, I will say, well, you know, take a look at the Python programming language. There are a bunch of tutorials in, you know, scikit-learn, which is a popular machine learning library within Python. And if you're comfortable already with programming languages in general, that's a great pathway into the realm of data science. If you're coming from a more kind of math, natural sciences, or statistics background, I often tell people to take a look at the R programming language. Used to be called RStudio, it's now called Posit. And there's a suite of packages called the tidyverse within that realm, which makes the practice of doing data ingestion, data wrangling, manipulation, cleaning, visualization, and then ultimately modeling really, really convenient and easy to do. And so, for instance, in our graduate data science program, we have a lot of students with zero programming background, and they may have taken a stats course as an undergrad a long time ago. We introduced them to the R programming language and the tidyverse in the first semester, and very quickly these students ramp up and are creating value. And about this time of year, they're about, they're about 7 or 8 months into their program at this point, so a semester and a half. They are all feeling quite capable with the skills that they've developed. And so it's not necessarily something, you know, that you have to take, you know, 4 years and a Ph.D. To acquire. It is something that, you know, with some, you know, grit and tenacity, you can actually acquire in a very short amount of time.
Mm-hmm. Yeah, that actually leads me to the next challenge, which is infrastructure and resources that we need to have in order to jump into that, right? So again, technology keeps evolving. Do you think somebody with just a computer, laptop can actually do that? Or do we need something bigger? Do we need like larger investments?
Well, I think it depends on what problem you're trying to solve. I know that for most of what we teach in our programs, all you need is a relatively cheap laptop, and you can get this done. Posit is a free and open source development environment for data science. This is what we use in all of our classes. A lot of the textbooks that we use are free and open sourced as well, so those are available for learning. One exception is probably our data engineering class, which touches on things like data architecture, data models, and kind of the broader SQL, world. And in that class, you might need access to some cloud computing resources, whether it's Azure from Microsoft or Google Cloud or Amazon Web Services, to be able to implement some of the kind of data architectures that are described and toyed with in that class. And in a company, I would say it's probably the same, right? You need somewhere for your data to live, and you have a choice to make. And you may have covered this with some of your other panels, but you could outsource that or you can insource that. And there are often legal constraints that kind of make that decision for you if you're a government entity, but not always. And so there are a variety and ever increasing number of consultants and other wonderful individuals in orbit in the Portland area that can help with those sorts of decisions. But in terms of the actual practice, right? If you're getting down and just getting your hands dirty, there are plenty of free tools available to use.
Yeah. I think this is a great opportunity. In order to wrap up this short conversation, and I'll yeah, there's so many things, right? Again, recently we are hearing about all this buzz on artificial intelligence and how disruptive these new tools, technologies, algorithms, services are coming to our lives in a way that is going to impact jobs, is going to impact the way in which we're actually interacting with the real world, is going to shift like economies, name it, right? What does that mean, like artificial intelligence for the data world?
This is something I spend a lot of time thinking about, and it interrupts my sleep every once in a while because I think it's quite a consequential issue for not just us locally, but for I think us broadly as humans. So let me try to pick a point to start on this. One, I personally and my faculty think that it's an important enough issue where we actually require courses in data ethics and policy within our programs, and that's something that differentiates us, I think, from a lot of other programs in the region and elsewhere. In terms of how we should be thinking about machine learning algorithms like ChatGPT and some of the other, Microsoft's recent kind of Bing adventure, there are a couple of things that I think students in the broader community should be thinking about. One, how do we design these algorithms in such a way that they are continuously optimized on human well-being? That's not a simple thing to accomplish, and it's going to take a huge number of really smart people to figure this out. And we need to put more of these folks out in the world with the tools to think about this sort of thing. And what do I mean by optimizing on human well-being? Well, when we build these machine learning algorithms, we are kind of training them on a bunch of historical data. It is unclear whether this historical data is representative of what's best for us as individuals, as humanity, et cetera. And so understanding how the data that these algorithms are trained on affects what they then give us in the future is of vital importance. The second thing I really worry about is the possibility for a kind of vicious reinforcing cycle. And we already start to see this in social media as an example, where our worst base instincts as humans cause us to click on things. And that creates more data for the algorithms to learn from, which then gives us a palette or a buffet of options, which are restricted to only those that were derived from our worst instincts to begin with. And this continues ongoing into the future to the point where it is no longer us training the machines, but the machines training us as humans. And so those two things, I think, together are really worrisome to me, and things that even if you're not into kind of the techie writing code part of this field, is an area where we need more folks to engage and think with us on how to solve these problems.
Yeah. Yeah, I know it can be. Now we are in the uncanny valley, right? And we are navigating through that. Well, thank you so much, Jameson, for joining this morning. And just as a last opportunity, would you like to share something else for everybody who's watching this recording?
Oh, goodness. I would say that, here's what I tell a lot of my incoming students, right? Data science is one of the most fun things you can do. It has more applications and outlets for your own creativity and your own kind of personal achievement than almost any other field that exists out there. You can apply data science to, of course, you could sell shoes for Nike, right? But you can track salmon migration in the Columbia River. You can create models to help place children into foster care. You can help political candidates identify successful messages in order to promote issues important to the region. Right? There are so many different ways that you can take the tools available to you and apply them in a way that's important to you personally. So I just want to encourage folks to really take a look at this field and get involved. We need more folks.
All right. Well, thank you so much for joining today. And we will be sharing links and resources about you, your work, and I appreciate this morning. And all right.